All right, let's look at example number 2. So, f prime of x. So you have x cubed plus 6 d high. So derivative of the numerator is 2x plus 1 minus pi d ho. So 3x squared all over ho ho. Really, that's why I said at the very, very beginning of the year. It's not the calc that's hard. It's the algebra. But that's the calc. We're done. It's all algebra now. It's all algebra 2. It's all, can you FOIL distributive combined like terms? So, equal sign, FOIL. First, outer, inner, last, group the next part, so put your negative on the outside, mark down your parentheses, do not forget to tag along your denominator. I always go back and just kind of re-FOIL, check all my exponents, make sure my values are correct. So I got 2, 4, 12, x cubed, 6. Distribute my negative. Again, consistently keeping my equal signs, lining them up, and keeping my math very, very lateral. So 2x to the 4th minus 3x to the 4th is negative x to the 4th. X cubed minus 3x cubed is negative 2x cubed. 12x doesn't have a friend. But before I do the 12x, there's a 6x squared. So did it. I had the 6. It has no friends, so it tags along too. Okay? That's your answer. Quotient rule answers are not pretty. They're long and they are messy. Remember or recall, all square roots become what? So this is going to become x minus 3x, x to the 1/2, all over x to the 1/2. Here's the thing. You can change this. What do you know about multiplying x by x to the 1/2? Well, the rule is to add the exponents, right? So instead of having these double x's, you can make this x minus 3x to the 3/2 all over x to the 1/2. So what that does is that simplifies that crazy, messy looking 3x square root x. So now we do our quotient rule. So you have x to the 1/2 times derivative of that numerator, so hody high. So derivative of x is 1. Derivative of 3x to the 3/2 says I have to multiply 3/2 by 3. So you get negative 9/2 x, and I subtract 1 away, so I get 1/2. So hody high minus high, yeah, all over oh hell. Now this denominator I would simplify. I would do the 1/2 times the 2 to turn it to an x. So you get x to the 1/2 minus 9/2 x. Remember, when you multiply these together, what do I do with my exponents?
Multiply.
I add them, not multiply
No,
them.
no. I mean, I'm sorry. Yeah, I mean add. 10 over 2.
Yeah. So we get 1/2 plus 1/2, which is 1, minus 1/2 here times x. So you have 1 plus a negative 1/2. So that's going to turn to a positive. So you have x to the 1/2 minus 3 times 1/2, which is 3/2, and then 3/2 minus 1/2, which is 1. All over x. So you have 1 minus 1/2, so we get 1/2. Negative 9/2 plus 3/2. Good. Sorry, minus. All over. What could I do to make that cleaner? What's 6 divided by 2? Yeah. And what do you know about my x's? I mean, I don't like having exponents with x's and whole numbers. So what could I do to clean this up? I could split my denominator. So 1/2 over x would become 1 over 2 square roots of x. Minus 3, because the x's would cancel also. So that idea of splitting the denominator could actually have occurred way up here before I took my derivative. So how do I split this problem to start? So what we're going to do, algebra at the very, very beginning. And I had said, okay, let's keep simplifying these x's. So in the numerator, I have x minus x to the 3/2, and in the denominator, I have x to the 1/2. If I had split this into 2 parts way back here, and I kept saying, all right, f of x is equal to x over x to the 1/2 minus 3x to the 3/2 all over x to the 1/2. What does f of x simplify into now? Well, x over x to the 1/2 becomes 3, x to the 3/2 over x to the 1/2 becomes 3x. 3/2 minus 1/2 is 1. Okay, take the derivative of that. Get rid of your negative exponent.
Some waste of time right there.
Do I not end up with the same answer? Was this not like 7 lines shorter? If you can algebraically simplify and get rid of the quotient rule, you're still mathematically doing the problem correctly. So there will be problems, and there are going to be problems because let's face it, once you start doing derivatives, the directions are going to say, use the quotient rule, use the product rule, use the power rule. The directions are going to say, find the derivative. So it's for you to decide, how could I simplify this? How could I make this problem the easiest for me? What, route you go is going to be a decision that you make. Algebraically, you may not think to do this. So you're going to do the quotient rule and you're going to have all of this. And it's not wrong, because didn't we get the same answer both ways? It's just a different way of thinking. And we all think in our own way. We all logically process a little bit differently. So you could be taught something, but somebody else might go, hey, I can do this. And I'll be like, yeah, you're right, you can. And you can totally get to that same answer. And there's nothing wrong with how you process to that same answer. There's an extension question to this one. I don't know, is it on yours? I think I actually deleted it because we ran out of space. No, it is, but there's just no space below it. Alright, so see at the top of your page, where it says, find the equation of the tangent line to the point, blah, blah, blah. And then it goes directly to example 4. There's just no space. So the back of this is blank, so you can do it on the back. I don't know how my spacing got all off. But let's find the equation to the tangent line, because that's the useful part of derivatives. It's finding those equation lines. It's finding the line of the next derivative and finding its values. So what do we know about the derivative? The derivative represents what? The slope of the tangent. So this function right here represents the slope of the tangent line for the original function. So the original function is f of x. They gave me the point 1, negative 2. So what that means I need to do is it means I need to find the value of the slope of the tangent at 1, negative 2 using f prime of x. So what I'm going to do is I'm going to find f prime of 1. Because f prime of 1 will represent the slope of the derivative at 1. So 1 over 2 square roots of 1 minus 3 will give me the slope of the tangent. Square root of 1 is 1. So I have 1/2 minus 3. So I get negative 2.5. Don't like it as a mixed number, turn it to a negative 5/2. How do you find the equation of the tangent line? What do I have to use? Point slope, right? Here's my point. Here's my slope. So you get y minus a minus 2 equals negative 5/2. X minus 1. You get y plus 2. If you want to clean it up algebraically or turn it to slope-intercept form, you can. But that is the equation of the tangent line. The last 3 examples really start to develop you towards a table that we're going to look at in probably about a few days, where they give you a table of values. So they'll give you like 3 functions, f, g, and h, and then they'll give you some derivatives that you have to find at certain points, and you kind of have to pull the table values and know your product and quotient rule and know how the values are going to fit in. So we're looking at like a modified or a much simpler version. So we're only looking at f and g, and we're only looking at 2 points. So we're looking at f of 5, f prime of 5, g of 5, and g prime of 5. Where the tables are typically 4 by 4s, so you have 16 numbers that you're sitting on, as opposed to 8. So they double. So the problem says, find f times g prime of 5. So this is my product rule, right? I want to find the derivative of f times g. So what's the product rule? Say it in your head or say it out loud. What's the product rule for f times g? It's first, so the f.
X times the derivative of g of x.
So first times derivative of the second plus
G of x minus g of x.
second times derivative of the first. Now what we have to do is we have to put in pi's. So we're trying to find the derivative of f times g, but now we're trying to find it as a number. So it'd be like f of 5 times g prime of 5 plus g of 5 times f prime of 5. That's where you go up to your table and pull down all the values. So f of 5 is 1. G prime of 5 is 2. G of 5 is negative 3. F prime of 5 is 6. Multiply. So 1 times 2 is 2. Negative 3 times 6 is negative 18. 2 and negative 18 is negative 16. Same thing. Using those same F's and G's, we're going to do it again. But now I want to find F divides G and G divides F. So I think we're looking at these two. Does it matter the order with which we would divide divisors? So like if I derive F over G and I derive G over F, the likelihood that they're the same is very, very small, right? So it's important to understand which one's the high and which one's the low. So in this case, what would this look like in terms of functions? So F divides G at 5 would be O, right, to start. So it would be G of 5 times D high, so the derivative of F at 5, minus high D help all over G of 5 squared. I'm going to tell you right now, one of the 9 for your response questions is usually involving this type of idea. There's usually a table, and there's a bunch of questions they ask you about derivatives and integrals from that table. And it's like part A, B, and C, just like this. Clean it up by plugging back in your numbers. So G of 5 was negative 3. F prime of 5 is 6. f of 5 is 1. G prime of 5 is 2. All over G of 5 squared. Negative 18 minus 2 all over a positive 9. Negative times a negative gives you a positive. Okay. Last one. So we have f of 5, high, Soho, G high, minus pi, E ho, all over, Soho. If you don't have the right placements of the primes, the negatives, or the 5s, you will typically lose points as well. They're looking for here, and then typically to here to here. So f of 5 was 1. G prime of 5 is 2. G of 5 is negative 3. F prime of 5 is 6. All over f of 5, which is 1 squared. So you have 2 plus 18 all over 1 or 20. Okay. In a weird order, or we'll just go over yesterday's homework tomorrow. That way the kids that aren't in here, I can go over the problems with them too. Okay, the homework's back in the book. 13 to 28 on 124. Do not support anything graphically. Don't worry about that. Just do the algebra. Do the math. Do the derivatives. Do the calculus.
That's on you right now.
Lots of time today. Yes, if you need to go